Okay, so today we're going to be talking about lesson 8.2, which is special right triangles. So there's two different kinds of special right triangles. There are 45, 45, 90s we're going to talk about first. And then there are triangles that have angle measures of 30, 60, and 90. So in a 45, 45, 90, you're going to have two 45-degree angles and a right angle. And then remember, because the triangle has two congruent angle measures, that makes the opposite sides congruent. That forces it to be isosceles right. So sometimes we'll talk about isosceles right triangles. Sometimes we'll talk about 45, 45, 90 triangles, but they're the same thing. Okay, so we're looking for a pattern of how these legs are related to the hypotenuse length. So we'd rather not have to do the Pythagorean theorem every time. If we can find this pattern, it'll save us time. So in order to figure out the pattern, I'm going to say, all right, let's say that the leg lengths are each 1, and let's see what happens. If we do 1 squared plus 1 squared equals h squared by the Pythagorean theorem, that'd be 1 plus 1 equals h squared, which is 2. If we square root both sides, we're going to get the square root of 2. Now, it can't be plus or minus root 2 because obviously that's a length that cannot be a negative root 2. Okay, so that means that the numbers would be 1, 1, square root of 2. So leg, leg, hypotenuse. Okay, now let's try if the legs are 3. What would that look like? Well, again, Pythagorean theorem, 3 squared plus 3 squared equals h squared. 9 plus 9 is h squared. 18 equals h squared. H would be the square root of 18. And if we break that down, 18 is 9 and 2 and 3 and 3. So remember, we can take out a radical, take the pair of 3's out as the square root of 9, which is just 3. And then we have a root 2 left over underneath the radical. So those numbers are 3, 3, 3 root 2. So if we kind of look at this pattern, you might notice that it seems like whatever the legs are, they're going to be the same as each other, of course. The hypotenuse is square root of 2 times that. So that means it would be like 7, 7, 7 root 2, or 23, 23, 23 root 2, or 18.5, 18.5, 18.5 root 2. Okay, so that's the pattern. So in a 45, 45, 90, which again is an isosceles right triangle, the ratio of leg to hypotenuse is x, x, x square root of 2. Or you can remember the hypotenuse is square root of 2 times either the leg lengths. So when you're looking at it on the diagram here, these obviously are your legs. It's going to be x, x, and x square root of 2. Now, if you want to think of it kind of like in simplest form, it would be 1, 1, square root of 2. So square root of 2 is about 1.4, and that's obviously bigger than 1, so the hypotenuse is longer than 1. Okay, so thinking about all 45, 45, 90 triangles, well, why are they all going to be similar to this 1, 1, root 2 triangle? Because they have all the same angle measures, the triangles are similar by what reason? Well, that's angle, angle, similarity, because obviously they have all 3 angle measures the same. Okay, so rather than having to do the Pythagorean theorem every time, we're going to save ourselves some time and use our shortcuts. So this would go 1, 1, root 2. So if you were going from a leg to the hypotenuse, you would multiply by root 2. If you were going from the hypotenuse back to one of the legs, you would divide by root 2. Now, since this one, the hypotenuse is 9 root 2, then that clearly should be 9, 9, 9 root 2. So your lengths are legs of 9 and a hypotenuse of 9 root 2. Now, the way that you would technically have gotten that is you would do 9 root 2 and divide out the root 2 because you're trying to make a smaller number, so you're dividing by root 2, and that would give you 9 for your legs. Okay, for the next one. So obviously this is going to be a 45-degree angle, and the legs have to be congruent. So if that's 8, y is obviously 8, and it would be 8, 8, 8 root 2. Okay, so pretty simple so far, right? We have The sides are in pretty simple format. So when it's going to get a little bit more complicated, it's when it's not quite as simple numbers. So for this one, I'm going to again say, all right, this is our 1, 1, and our root 2. So we know that y is the same as the other leg. So 4 root 6, 4 root 6. Now to go from a leg to the hypotenuse, we're going to multiply by root 2. That means that you'll take 4 root 6 and multiply by square root of 2. So we're going to do some radical practice because I want to make sure that we're good with being able to simplify that. So 4 square root of 12, the square root of 12, that's 4 and 3 and 2 and 2. So that's 4 times 2 root 3 or 8 root 3. Okay, so that looks a little bit weird because it's not as easy to tell that it's still the ratio of 1, 1, 1 root 2. But if you were to take 8 root 3 and simplify it, so you don't have to do this, but I'm just going to show you just to check. If we were to go backwards, if we take 8 root 3 and we divide out the root 2, well, remember we have to rationalize, so we'd multiply by root 2 over root 2, which would become 8 root 6 over 2, which is then 4 root 6. Okay, and that would check. Now, again, you do not have to do that every time. I'm just showing you how those weird answers really do check. Okay, so I just did something a minute ago that was called rationalizing denominator. So just a reminder, I think we've talked about this recently, but you definitely talked about this in Algebra 1. Whenever the denominator is a square root, we're going to simplify by getting rid of that radical on the bottom. It's considered unsimplified when there's a radical in the denominator. So we're going to multiply the top and the bottom by whatever that radical is. Because what is square root of 2 times square root of 2? It's 2. And then you can take the numbers on the outside and divide them and get 6 root 2. Okay, so for this one, our hypotenuse is 10. So we've got a 1, and a root 2. So again, to go from the hypotenuse to a smaller leg, because the legs are always shorter than the hypotenuse, we'll take the 10 and we'll divide out a square root of 2. Okay, we're cutting it by root 2. And then because that's considered unsimplified, we're going to have to rationalize that. So that becomes 10 root 2 over 2, which is, you can divide those numbers. That divides out and becomes 5 root 2. So it would be 5 root 2, 5 root 2, and 10 are your side legs. Okay, that is the end of 45, 45, 90. I'm going to make these 2 separate videos.